Greetings. Today I'm going to talk about the presentation I have made for Theory of Computation. My name is Ramit Bose and my registration number is 21 BCE 1316. So the topic I've chosen is application of finite automata in search engines. So let us see the contents what we are going to talk about. So the contents are theory of automata, types of automata, finite automata, types of finite automata, applications of finite automata, search engines, application of finite automata in search engines. There is also a demo, inverted index search algorithms, understanding the algorithm. There is example. There is pros and cons of the algorithm, and finally there is conclusion. So, what is the theory of automata? Automata theory is a theoretical study in computer science and mathematics. It refers to the study of abstract machines and automata, as well as the computational problems that can be solved using them. An automation is an abstract self-propelled computing device which follows a predetermined sequence of operations automatically. There is a pictorial representation you can see. These are the classes of automata. There is Turing measure. We see it from the inside to the outside. So there is a combinational logic, finite machine, push-down automata, and finally the Turing machine. So these are the types of automata. We can see there is finite state machine, push-down automata, linear bounded automata, and Turing machine. These are the pictures you can see. So let's talk about finite automata. Finite automata (FA) is the most basic machine that can spot patterns. It has finite number of states and a set of guidelines for changing between them. In essence, it is a model of a digital computer that is abstract. The automation described in the image consists of states represented by circle and transitions represented by arrows. As the automation sees a symbol of input, it makes a transition or jump to another state according to its transition function, which takes the previous state and current input symbol as its arguments. Let's see the types of finite automata. There are two types of finite automata, DFA and NFA. DFA refers to deterministic finite automata. A finite automata FA is said to be deterministic if corresponding to an input symbol there is a single resultant state, that is, there is only one transition. A deterministic finite automata is a set of five tuples represented as m equals to q, sigma, delta, q naught, and f, where q is a non-empty finite set of states in the in the finite control. Sigma is a non-empty finite set of input symbols. Delta is the transition function that takes two arguments, a state and input symbol, and returns a single state. Q naught is the starting state, one of the states in Q, and F is a non-empty set or final states accepting states from the set belonging to Q. There is also NFA, which refers to non-deterministic finite automata. A finite automata FA is said to be non-deterministic if there is more than one possible transition from one state on the same input symbol. A non-deterministic finite automata is also a set of five tuples similar to DFA. The only difference is there is more than one possible transition from one state on the same input symbol. So these are some important points about DFA and NFA. Every DFA is NFA, but NFA is not DFA. There can be multiple finite states in both NFA and DFA. DFA is used in lexical analysis in compiler. NFA is more of a theoretical concept. So these are some of the applications of finite automata for designing of lexical analysis of a compiler, for recognizing the pattern using regular expressions, for the designing of combination and sequential circuits using Mealy and Moore machines, used in text editors for the implementation of spell checkers. So let's see what are search engines. Search engine is a software program used to do web searches. Is known as a search engine. They conduct systematic searches of the World Wide Web for specific data that is defined in a text-based search query. Search engines also retain real-time information by running an algorithm on a web crawler. Unlike web directories and social bookmarking sites, which are edited by human beings. So you can see few of the search engines available to us like Google, Microsoft Bing, DuckDuckGo, Brave, and more. Search engines work through three primary functions: crawling, indexing, and ranking. In crawling, it sort the internet for content, looking over the code or content for each URL defined. In indexing, they store and organize the content found during the crawling process. Once a page is in the index, it is in the running to be displayed as a result to the relevant queries. In ranking, they provide the pieces of content that will be best answered and the answer to the search query, which means that results are ordered by most relevant to the least relevant. Applications of finite automata in search engines. String searching with DFA-based algorithm and finite automata algorithm for pattern searching. So this is how the algorithm works. Like the user gives a search query to the search engine gives the input to the algorithm, and the algorithm gives an output to the search engine, and correspondingly the search engine shows the relevant web pages to the user. So there is a demo I have shown here that whenever we search anything on Google, for example, if we are searching for the word entrepreneurship, we don't have to write the entire word. We are just typing ENT and the word entrepreneurship pops up in the search result. So how does it work? Let's see in the further slides. So it works on inverted index searching algorithm. It is a popular way of implementing searching in search engines and databases. Hashmap like data structures is used. Word to web page allows fast full text searches. The types are record level inverted index and word level inverted index. A record level inverted index contains a list of references to documents for each word. A word-level inverted index additionally contains the positions of each word within a document. Inverted indexes are expensive to update, so search engines typically reconstruct their index from scratch on periodic basis. Documents are normally stored in list of words, but inverted indexes invert this by storing for each word the list of documents that the word appears in. Hence, the name is inverted index. Let's understand the algorithm. Googlebot processes each page it crawls to compile an index of words and their location on the page, as well as information in key content tags and attributes. Googlebot cannot process all content types, such as some rich media files or dynamic pages. When a user searches, Google's machines search the index for matching pages and return the most relevant results based on over 200 factors, including PageRank. PageRank measures the page's importance based on incoming links from other pages. with higher quality links contributing more to the site's page rank. To rank well in search results, it's important to ensure that Google can crawl and index your site correctly, and to focus on obtaining high quality links based on the quality of your content. So here is an example of inverted index searching algorithm. Let's say we build a search engine which can search contents of a sentence, and suppose these are the three sentences which are indexed as 0, 1 and 2. The sentences are: blogging makes me happy, blogging is easy, and it is easy to be happy. Then we would store these sentences in inverted indexes like this, which you can see in the picture in the right hand side. The record level represents the document ID where the words are stored, and the fully inverted sets uh, represent the document ID in the first number and the location information in the second number inside the parenthesis. So, if you want to search all the three documents for the word happy blogging, then you would grab the set according the record label only, uh, which is shown here in the below. That is, we got 0, comma 1 for blogging and 0, comma 2 for happy. Then we would intersect these sets, coming up with the resultant set, which is 0. So to further explain what these records are, let's say blogging has the record level 0, comma 1, which means the word blogging is present in line number 0 as well as in line number 1. And in fully inverted set, we mention the where the word is present and also the location. So the word so so for the word blogging in fully inverted set, it is 0, comma 0 and 1, comma 0, which means the word blogging is present in line number 0 and position number 0, as well as it is present in line number 1 and position number 0. So these are the pros and cons of the algorithm we just saw. The pros are: it is economical, fast, has a faster computing rate, it is user independent, has high quality and have high flexibility. And the cons are: it decreases performance on inserts, updates and deletes. It takes up space, uh, monocasing of values in index fields, and indexes take additional disk space. So, as a conclusion, through this presentation, I would like to conclude that in this new age of technology being used in our day to day lives, search engines play a very crucial role in our lives. And Finite Automata makes it possible for the search engine to function under its immense application. Thank you.